Howdy, everybody in YouTube land. I wasn't initially going to do a video on this, but I got so many requests that are, hey, you should do a video on doing this. Because these are fairly straightforward, but people get a little bit of fear and frustration on how to get these apart, and I understand it because I did too. These are very not intuitive to take apart because they are glued together. So I wanted to do this video on not just recapping these, but I wanted to do a video on at least trying to take this apart. Now, there's two different versions of these. We have the APS 46U, which is a higher amperage used for the color models. And then we have the APS 20U, which is the 2 amp model. And this is the most common. This is used for your PowerBook 100, 140, 145, 160, 165, 180. While this one's used for the 165C and the 180C. They will work interchangeably as long as you're using the 3 amp on a 2 amp model. If you're using a 2 amp on a 3 amp model, it won't work. But the 3 amp model will work on a 2 amp model, but you could have problems if the battery is still good and you're trying to charge the battery, because the battery will try to consume as much current as it can to charge it, which could be threatening to the battery. But if you're not using the battery, like in my case, then it is safe to do this. So anyways, I am going to position the camera so we can see how to take one of these apart. Alright, so unfortunately the workbench up here is plastic, so I can't do this on the workbench. So what I've done is I've positioned the camera to the floor. That way I can kind of document how this is done. So the way to get this apart, there's a couple different ways to do this. You can squeeze it with a couple of pencils and a vise, which I've not had that great a success with. I do, but I also don't. The other way to do this, and there's a Tinker Different thread on the internet that goes into details on how to do this, but see, we have a cable here and we have a strain relief. If you lift up this strain relief, you can actually get a flat blade screwdriver in between the two points here, and then you can use a hammer to drive the screwdriver in. So you have to be careful because you don't want to break the power supply, right? So what I want to do is I'm just going to stick my foot in between these two, grab the poundy device here, and grab a wedgie device, and we're going to go in here like so. Carefully get it centered as much as we can, and we're going to tap at it. And it will pop apart just like that. So at this point, you can just keep driving it in and destroy the circuit board, or we can just slowly figure out a way to crack this loose like so. And we're gonna just kind of like do this by hand, which is easier said than done. And sometimes you got to take a bigger screwdriver and crack it apart like this. It's not exactly the most intuitive thing to do. So I got my finger in there now, so we can actually get in here and pop it like that. So there we go. Now we're cracked loose. I can slide the cable out, and then now the power supply is opened up. Alright, so that is how you take apart one of these PowerBook style power supplies. The thing about popping it apart that way as well is it leaves very minimal, if any, damage on the case itself. So when you glue this thing back together, it's going to look like nothing really ever happened to it. So, okay, the next thing we want to do is we want to do a quick inspection of all the components in the board. It looks like our hot glue blob has broken loose. So we want to take a quick inspection to see if there's any damage in this board, and it doesn't look like there is. Also, there's the screw to take it apart right there. So let's get this screw out like so. So now we have this guy where we can just get it out. And there we go. we've extracted the circuit board from the case. Okay, so I want to document here the capacitors we have. So we've got a 82 microfarad at 400 volt, which I'm not going to change. These things hardly ever go bad. It's not impossible because I have seen them bad, but I can count on one hand how many of these I've ever had to replace out of the hundreds of power supplies I've had to do over the years. But these, on the other hand, these are a problem. So I want to document what we have. We have a 16 volt 470 microfarad. We have a 2200 at 16 volt. We have a, pretty sure this is a 47 at 50 right there. These are all low ESR types as well. But there is a fourth one, and that's right here. It's a 10 mic 16 volt, and it looks like a tantalum capacitor, but it's not. If you look closely, that is actually an electrolytic disguised as a tantalum. These are notorious for leaking. I don't see any signs of it here that I can tell. Maybe a little, but maybe not. There's no signs of it there. So that is not leaking whatsoever. However, it will with time. So we're just going to go ahead and change it. I'm going to turn on my soldering iron equipment, and we're going to get those out. The other thing we want to do is inspect the bottom of the board. We're looking for broken solder joints. I tend to touch all these up. You're looking for capacitor spooge leakage, which I don't see any evidence of that here. It looks like for this particular power supply, we've caught it just in time. This is the APS 46U, which is the 3 amp model. And most importantly, we do not have a hybrid IC. Instead, we've just got a traditional Mitsubishi IC right here that's running the power supply. And this is what I typically see on Sony's newer stuff, like that's in the Macintosh 2SI. May not be the same chip, but it also might be. I don't know. So that's what we got going on here. Also, I want to try to peel all this glue off because we're going to have to re-add this glue anyways, because this is part of the support to stop this board from moving around, because this board is very, very weak. And it will eventually vibrate loose, crack solder joints and stuff like that. And you don't want that happening inside a sealed enclosure because you can't get to it without going what we just went through. So we want to make sure this stuff is glued in place and this stuff can't move everywhere as easily. So that's what we're going to do. So let me get the iron warmed up and we're going to start extracting parts. Alright, so now it's time to start extracting some components. Okay, so the next thing we got to do is pull this board, which is going to be hard to do because there's a piece of silicone blob in the way. If you're not careful, you're going to bend the these pins too, so we got to straighten those back out. But I get why they put that silicone blob there, because again, you don't want this stuff flying off, right? So I'm going to set you aside after we remove this little blobulating thing, and be careful because we don't want to crack the circuit board. So there we go. Remove that out of the way, and then we need to like get this out of the way because it's in the way and I don't care about that. We're going to use hot glue to fix that. So okay, so now we need to extract the capacitors. So I'm going to do the through hole ones first. We're going to remove you here. So there's that one. This is an SME series, United Chemicon or Nippon Chemicon. It's one of those two. Let's see, do we have any leakage? No, we do not. So that's good. So now we got to remove you. Oh, I heard that sizzle. And I smell it. Oh yeah. Let's take you and remove you out. Do we have any leakage? Yes, we do. This one's leaking, but it only just started. We only got a little bit of remnants in there, ever so slightly. So, yeah, that's gone. And this is the LXF series, which is a known bad series, so just FYI. The SME, no, this is a KME. This one I'm not sure. This one actually might be alright, but we're changing it anyway. The SME is a known bad series. Now we got to remove you. This 4700 or 47 at 16. Got it wrong both times. 470. Now this wire is right in the way, so I'm just gonna clip you out just to make it easier to work with here. And then what about you? Yes, we've got wet spot right around the pin, so that's also gone. Okay, the next thing I do is I clean the PCB with some alcohol just to get rid of all the cap spooge, which, yeah, you can see how brown the Q-tip is, so definitely got capacitor goo on the board. Over here we shouldn't. We'll clean that anyways, and that's fine. Yeah, but you can see how brown and yellow that is. That's not just flux residue, that's capacitor spooge. So that has to be replaced. Okay. Now we just start putting new parts in. So in this case, this is what I have on hand. I have a 2200 at 25, which is, should be this, no, this is a 16. I have 25s. This is a YXJ series Rubicon, low ESR. Capacitor, so we're just going to put you in there because that's what I have, and it will fit. There's no problems there. So we're going to solder you in place. What I like to do is get it soldered first or started, and then I'll position it in. I'm sure there's better ways to do that using like helping hands or whatnot, but I'm just used to doing things a certain way, and this is how I do it. So don't mind me. Oh God, that smells terrible. Oh yeah, that smells rancid. Okay, so we're good there. Next, we need 470 at 16. This is also a low ESR capacitor. This is a PET series from, no, YXJ from Rubicon. Same thing, YXJ from Rubicon. So that's what we're going to shove in here. Make sure it's lined up is good. Now this doesn't have exactly the same lead spacing, so it fits in there a lot more snug, so it won't fall out on you. Oh yeah, I can smell the cap juice. Let that boil off a little bit. Now what happens sometimes is the soldering iron may not have enough wattage to get in here, which in this case I don't have a problem, but sometimes it doesn't. And when it doesn't, I use my desoldering iron, which is a much hotter wattage iron, to solder this stuff sometimes. Okay, so that is done on that one. So the next one I need is a 47 at 50 volt, which is not a low ESR capacitor that I can tell. Which it probably actually is, because that's coming right off a rectifier diode, which is probably the voltage that powers this circuit. Because the way a lot of these switching power supplies work is you have a kickstart voltage that comes from the primary power from this circuit over here, and then when it starts it goes into a closed loop, and there's a rectifier diode right off the transformer which feeds VCC into this. It takes over. and then it goes into a closed loop. There's a lot of power supply designs that do this. And I'm not sure why. I don't know if it's for power factor correction. Probably. But I don't know. I don't have the theory enough in mind to figure out why that is. So we got we got to solder that diode back again because we missed it. Okay. So there we go. That capacitor is installed. So now all three of those capacitors are in place. Now, the next thing we have to work on is this board right here. This has that funky 10 mic 16 volt surface mount. So what I do with these is I crack them off the board right here carefully. Just like that. And that way I can lift it up. And what I mean by cracking is there's actually a solder pad right here. So I take that and I move you out of the way, get it nice and warm. Move that pad out. And then what I do is this isn't corroded, so I can do that. The corroded ones I have to cut them. But then I do that and I remove that capacitor. Grab my desoldering iron. And I use that to pull the solder off. You can use braid or anything like that. I just use that. And just FYI, the board does not have any markings. I lost the capacitor in the floor. I'll have to find that later. But the board does not have any markings where the positive and negative are. So when you pull these caps off, pay attention. In the case of this board, we know the capacitor went here, which is the negative is on this side. So we got to make sure that the capacitor has the negative facing this way. So what I'm going to do is just bend the leads like this. And then I go and bend the leads back this way. Try to straighten them out. And then I just clip them like that. Could you use a tantalum here? Yeah, probably. But I have these very small electrolytic capacitors. And I can lay them down on their side just like that, which will allow me to solder them down. Now remember, you have to be careful because you don't know if you can have the clearance here to do that. But in the case of this, I know that I do. Making sure there's no shorts to anything, doesn't look like it, and we're good. So there we go. This power supply should be repaired. So I'm going to reinstall this board like so. Got some bent pins, but that's not a big deal. We're going to reinstall this board. Tack it down in here. Tack it down over here. Make sure we're good, and then we start resoldering everything. Now, this is the opportunity that I take to resolder all of the solder joints that might be suspicious or bad. Not always is that the case, but sometimes it is. Like I've got a ring crack around this lead of the transformer, so we're just going to go ahead and hit all of these transformer solder pads up because this is a weighty item, and weighty items tend to crack free from the board with thermal cycles, mechanical moving around, you know, that kind of thing. So I just want to make sure that we're all good there and that we're not going to have a problem. So these are just preventative maintenance things that you don't have to do, but you know, if it's a power supply that you have to take physically apart and put back together and it requires you to use glue to put it back together, you kind of want to take care of everything while you're in here. You know what I'm saying? So perhaps that's probably the best course of action. So that's what we're going to do. We're going to take care of every potential problem child spot that I'm noticing off the top of my head. Now there's not very many solder joints in here, so at this point you could just go ahead and do them all, which is kind of what I'm doing right now. So why not? Let's just do them all. So unfortunately that soldering iron is just not very powerful, so I like to just use my, like that. It's so much faster, so much easier. Now this can cause premature wear on a desoldering iron tip, but I change these tips so much anyways, I mean it doesn't even really matter. So that's basically everything on this bottom of the board that matters. So everything on the bottom of the board that matters. There we go. All good. One last thing we want to do quickly on the actual daughter card here, you want to just touch up these connections here that tend to pivot with thermal expansion cycles like that. Alright, we are done with this board, so all we need to do now is reassemble the power supply, glue everything down, and wrap this one up. So that's it for this one. I'm going to go ahead and move on to the more common APS-20U. So the next one we're going to do is we're going to work on the APS-20U. Now this one is only 2 amps versus a 3 amps, and we're going to perform the same exact process. We're going to fit the little flathead screwdriver in there, and we're going to crack this one apart to try to have minimal damage as possible and see what we got going on inside. I'm sure we've got leaking capacitors in this one as well. I don't know if they're the same ones yet, so we're going to crack this apart and find out what we got going on. Alright, so this is the APS-20U, and there are some differences. The biggest notable difference is the DC connector does not have the wound choke on it. Instead, they put it on this little card right here. Slightly smaller transformer, but otherwise the design is overall very similar. However, one big notable difference is they use a hybrid IC on this one, just like the Macintosh Portable. The problem with these particular chips, this epoxy absorbs moisture, and when it does, it becomes conductive. Now this is late enough that it may not have the same problem as the early mid-80s stuff did, but Sony's mid-80s stuff, mid-late 80s stuff had a problem with this going really conductive. So the only way to fix this is to either bake this out completely and drive all the moisture out so it's not conductive anymore, or you could depot it by putting it in a vat of acetone for 24 to 48 hours. This stuff is so on there thick, this probably would need closer to 48 to 72 hours to get this stuff off. A third option would be to reverse engineer it and just make a new one, which I have already done that with the Macintosh Portable version, which is in a different video you'll see shortly. But I don't know the order of the videos are going to come out, if this one will come out before or after, but the point is you'll see that this is a different design. However, I noticed with this one you can see a bump in the middle where there's a chip in there, so I'm wondering if this is the same chip that they eventually moved onto this card with the other design. So once again, we have the screw hole here, so we can remove the screw and pull this power supply out like that. We inspect it. I don't see any corrosion damage on the circuit board, and I don't see any remnants of crap inside the case. And we have nothing else left going on that I can see. The board's very similar in design though, so alright, let's get our capacitors logged and see what we got going on. Alright, so what do we have on this one? Well, it's going to be easier to work on if I remove some stuff out of the way. cable right there, which it looks like we've got hot glue in the way here. So there we go, that's out. Now see, they put the filter choke on the board itself, so that's kind of cool. Alright, that's out of the way. We have a, let's see, what do we got? We have a 1200 at 16. These RSH caps are bad. We have a 180 at 16, which is an oddball value. I don't have one of those. I'll probably end up putting a 220 in there. I have these 1200s. This one is a, I don't know. Let's figure it out. This one is an 82 at 16, which I'm going to have 100. I'm not going to have any 82s. I'll have 100s. That'll be more 220. And then, see, Sony was always weird about putting arbitrary values in their power supplies. I don't know why. Alright, what do we have on here? Well, we've got this Sony 2D1V1 or SH, I don't know, it's some proprietary IC. We have a 33 at 35 volt, which I doubt I'm going to have a 35 volt. Not likely. I have to look in my stash. One UF50, I have those. That one's that's a wild card. I'm going to have to look in my stash. I know I got 47s at 35 volt, but my worry with this, well, hold on. That positive is connected to this pin here, which is connected to you right here. What are you? Ah, we have a diode there, which is connected to another diode. Oh yeah, alright, it's connected to, okay, so this is the converter filter capacitor that powers this IC, so that's probably not critical. I can probably put a 47 there and be okay with it. I mean, sometimes you can kind of get away with certain situations depending on what it is you're working on. You can't just go subbing capacitor values willy-nilly unless you kind of know what you're working on and what you're doing. I understand switching power supplies enough to know what I can sub and what I can't to a certain degree, but not everybody knows that. Oh yeah, we have a 47 at 50, so we have those. This is the exact same one. That's the exact same one that's in the other version, the newer one. It's the exact same one there. That is in like the absolute worst spot too to get to. No signs of leakage. I didn't expect that to be leaking because it's probably a standard capacitor. You, on the other hand, let's see. These boards are marked where the positive and negatives go. No, don't see anything there. So this one had not started leaking yet. Get that out of the way, because again, we got to get the cap in there. Let's check you. These are hard to do. Because they're folded over. There we go, that's out of the way. What we have here, a little bit of corrosion here on the negative lead, but nothing serious. So that one had just started. Let's see, what about you? Once again, there's freaking hot glue everywhere. don't see anything on that one either. So I might have got lucky with this one. Be careful with this stuff. It's brittle, it's old. You're going to have all kinds of weird things like that. So that's it. We have a 1200 at 16. We have a 180 at 16. And we have a 82 at 16. And of course we have a 47 at 50. Then we have a 33 at 35, which I don't have. And then I got a 1 at 50, which I do have. So where do we go from here? Well, we got to start throwing caps in it. So 47 at 50. Oh, the primary filter cap is a 47 at 400 volt. So that's it over there. And in fact, I doubt it's leaking. No. It's not. It's not leaking. You'd hear it. And you'd smell it, which you can't smell it from here, but I would certainly smell it if it were leaking. It smelled like a fish factory on a hot day, which fortunately is not the case here. So we're going to go you in there, put you in there, and there we go. I was never a fan of capacitors stacked right next to heat sinks for obvious reasons, but in this case you kind of don't have much of a choice just due to the compact design of how this thing is set up. Alright, now as for the other capacitors, I'm going to have to source them out of my stash, so give me a moment. Well, unfortunately, I do not have any 33s at 35. I got tons of 33s at 25, but not at 35. So we're just going to have to make do with 47s at 35, so we'll have that. God, I'm getting low on this stuff. I'm going to have to order up some 220s at 25 because I am out. So 1200, 9,000 hours. So this will work in this case here. So we're just going to put you in there like so. So there we go. Just going to add some new capacitors in here like so. So that's done. We got, let's see, that was the 220 or 180, but we're just going to put 220 in there because that's what we have on hand. That is what we have on hand. Now, unfortunately, these are not low ESR caps. This power supply really wants low ESR, but it's what I have, and the primary input capacitor, which is over here, is low ESR, so we should be alright. It's not going to be super hyper insanely critical. For the amount of time you're going to use something like this today in 2024, it's not likely to matter. I mean, if I was going to use this power supply plugged in all the time for the next 10 years, I might be concerned, but to be honest, most people's use cases for these machines might be an hour out of the day to play around with an old game, and that's about it. It'll get unplugged, it'll get thrown in a bag on a shelf, and then forgotten about. And unfortunately, that is the sad reality of this type of hardware. So, but that's okay. As long as it's good to go for when you want to pull it out and use it, you're good. You can. So, I'm not going to judge anyone on that, including myself. So, we got you out of the way, you out of the way. So I need an 82, which in this case is going to be a 100. Low ESR, which is... Where are you? There we go. I thought I had those pulled out, but I guess not. Low impedance 100 microfarad, which we're going to use for this 82 that sits right here, which it will work fine. These aren't timing capacitors, they're just filter caps. that run. Okay, so that one's done. Now I just have to do U. So move you out of the way. I already got U, so we're good. I just got to remove U. So we do not have any 33s at 35 volt. I'm going to have to order some. United Chemicon SRG series, whatever that is. So it's a 33, and this is a 1 microfarad at 50 volt, which I do have. Not likely that it's bad. It's rare that these go bad. I've not seen one of these go bad, but I change them anyways. So 1 mic, 50 volt, which I have brand new versions of the same exact capacitor. So I have you. Okay, now the one thing you got to watch out for are bad solder joints on this board as well, and I can see a dozen of them. Like there's some ring cracks here that need to be taken care of. I do not have a replacement for this hybrid yet, so I'm not going to worry about depotting it or anything like that, because I have another one of these taken apart, and I have this in acetone, and it's been almost 48 hours and it's just now starting to get a little bit soft. So this could take up to 72 or longer hours to get this epoxy soft enough to get it to peel off. So I don't know. It's the best I can do right now. So 47 is what we're going to put there instead of the 33. And I don't have a low profile 47 at 35 volt because 35 volt caps and low profile are already hard enough to find. So we're just going to use U. I've got 47s at 50, but so what I want to do before I get too carried away is, will this actually fit in here? Not really. So what we're going to need to do, I know why it's low profile now, we're going to have to go, we have to bend it over like this and sit it right here. Then it'll fit in there properly. There we go. Okay, there. Now I can put this guy back together. And it just barely fits where this hybrid is clearing this capacitor, just barely getting through there. So we'll grab you, solder you back together like so. Ow, that felt great. Iron hot. It's fine, fine. The skin will grow back eventually. So the other thing I want to check out real quick is, like I did on the other one, I want to go through and double check and all of these solder joints, especially in the transformer area, because they tend to expand and contract and crack and cause problems. So we're just going to go ahead and take care of that, because I, again, do not want to take this thing back apart again. And we got some cracks over here. Everything else so far looks okay. I've only seen a couple. The other thing we want to do is we want to resolder the bridge rectifier, which is on this heatsink right here, and it can expand and contract and cause all kinds of fun. Because the thing is, you have to understand that these power supplies are 30 plus years old as of the making of this video. So you gotta make sure that everything here is good to go as far as we can. I mean, nothing's perfect. If you want it perfect, you'd have to replace every semiconductor and everything on this power supply with brand new parts. You know, but that's just not practical. The other thing you could do is get a small little Meanwell power supply and hide it inside that gray enclosure. There's plenty of room to do that, and that is certainly an option. But in my case, I try to keep originality as best as I can to a certain extent. So because I like working on original power supplies, and I'm generally decent at getting these power supplies working when they don't work, I tend to try to keep the original ones in place. Because there are some cases that subbing the power supply out for a modern one is not practical, like very high current mainframe type computers, SGI Crimson machines, things like that. It's just not practical. But in the case of something like this, you can certainly use a generic power supply. You could go get a 7.5 volt 2 amp Chinese toilet on Amazon if you want, and it'll work perfectly fine. But it doesn't look right, and it's going to throw off so much noise, as we've seen on this channel before, that it practically makes it impossible to operate in the analog domain. So if you're like me and you have analog broadcasting equipment for fun purposes, you won't be able to use it because the Chinese power supply will be throwing off so much noise that you're going to be like, what's going on? What's wrong with my setup? Well, that's why. Okay, that is done. So the next thing we need to do is inspect our joints over here, and yeah, we got issues going on over here, of course. This one's going to be hard to work with because of the wire. So you got to resolder you up too, because you're also a problem. Alright, plug you in so we can start gluing things. Let that warm up while we're soldering all of this in place. We're going to solder you, and you. We'll add some extra solder to it because that little joint carries some current. Okay, a little solder there. Anything else that I missed in this power supply? Probably not. Well, yeah, there's a few. That should do it. There we go. This power supply has been fully recapped. So now we just got to put it back in here, which is easier said than done because you have to navigate. There's like hooks in the front here that hold the PCB in place that you have to navigate around. Actually, before I even I'm getting too carried away because I got to get some hot glue in here, but before I do that, I'm going to go ahead and get this screw back in here. It's easier to get to that screw with this design because the wire's not in the way. Alright, so that should be good to go. So now I'm going to get some hot glue. We're going to dab some of that stuff in here where it needs to go so things don't move around, and we're going to do it. So that cap is all cleared. We're good there now. We're good. Alright, so that is it for repairing the two versions of this power supply. I'm going to go ahead and do the rest of them off camera and skip ahead here, but that should sum it up. Yeah, this one had leaked pretty badly because I'm in the next 46U, and this one was so bad I had to grind the board down and clean it up. I think this was the worst one I've seen so far. Let's see, is this it? Yeah, this is the worst one I've seen so far. That one is showing signs. Yeah, you can kind of see it leaking a little bit there. Oh yeah, this one's really, yeah. So I had to like clean all that up. I got the new caps in there though. So the next one in, I didn't film the process because I already got that in the last two. So just wanted to add this one in because of just how nasty this was. Now we're into APS 46U number 3, and this one's just as bad. You can see all the pitting from the corrosion of this capacitor. So these things absolutely need recapped at this point. And I wonder if it's like storage conditions that are contributing factor to this. And yeah, as I suspected, the through-hole capacitors are reflecting the same state as everything else. Gotta change them. And there we go. We're now about to close up our last one. So new caps are installed, got the hot glue curing a little bit, and we're gonna sandwich this guy back together. All right, they're all done. I got them all date stamped, so I know that I've already been through these. They're all buttoned up and glued up and haven't been tested yet. I know they say overconfidence makes you careless, but you know what? I have a good feeling that they're all fine. So we're going to go ahead and test them anyways and make sure that they are, but they should be. So I got them all tested, just doing some dry checks with the multimeter, and they're all testing at about 7.78 to 7.8 volts, which is a little high from 7.5. Now, if one or two of them were high, that would make sense, but they're all that way, which means they were adjusted that way. One might be a fluke, two might be a coincidence, three, you have a pattern. With all five of them testing exactly the same way, that makes me believe that they're just adjusted that way. And two of these guys were in active use anyways, so they're all probably fine. But I'm going to go ahead and grab out a cheapo PowerBook that I don't care if I blow up and give these guys a test. Well, I went to go use my 145B, which I remember just recently doing a video on. As soon as I opened it up, it like blew apart. I swear, I'm really starting to hate these things. Now, this is one of the ones I epoxied and glued the standoffs. I didn't actually put replacement 3D printed parts in, so we're going to be stuck doing that, unfortunately. And actually, the screw blew out of the front bezel, too. That's weird to me. So, alright, well, we're going to have to move on to the next one. This one I just recently worked on, so hopefully this one. Ooh, I don't like that sound. This stuff just scares the crap out of me. Alright, yeah, that one didn't blow apart, so. Ugh. Oh. Alright, let's try you. Make sure you work. Yay, it does. We're good. Adjust the screen. Oh, too much. There we go. That's right, I just put a blue SCSI in this thing. Alright, well, that power adapter works. So we're going to keep going through these one by one and making sure we're all good, which we should be. Alright, we are on the last AC adapter. This is taking me a bit of time, but so far I've not had any issues yet. So let's see. Everything seems to be working. Trying to figure out why. There's something weird with the control panels. It won't anyways. Moving right along here. WeatherBot. I tried to play with this. This is a brand new program, well, new-ish, that allows you to view weather on your vintage computer. The problem is it's not working. It's looking for a server that doesn't exist. It just continually gets stuck here, so not sure. I mean, I know the internet or the laptop gets on the internet because we're setting the system clock and all of that from the network time server, so I'm not worried about that. But Something's up with that software. Anyway, so moral of the story is that was my last charger to test, and it seems to be working fine. So I can go ahead and get this thing put off to the side here. You know, after dark on a passive matrix black and white display looks kind of hilarious. But, alright, well, we'll quit that program because it doesn't actually work anymore. So that is it. That AC adapter is working perfectly fine. So we are good. Turn my PRAM battery off so it doesn't run dead. So we're good. So anyways, that was a quick little video on working and fixing some PowerBook chargers. So they're ready to go. I got them all put up and out of the way for now. Now I have to deal with more Entropy related problems. But anyways, if you enjoyed this video, don't forget to hit the like and subscribe and all that fun stuff. Please feel free to leave a comment if you have one. Until next time, guys, thank you for watching. Yeah, I don't know. It's the consistency of rubber because look, I can just... This is rubber. It's not hard at all. Well, I know it was a good mix by hand, but I mean, look at this. You can see it really spongy. See that? Something definitely went wrong. It's like rubber. Here's another interesting observation. So I peeled it off the plastic. Look what the JB Weld has done to the plastic. It's like it almost in a way melted or disrupted the plastic. So I wonder if this plastic just is not compatible with this version of JB Weld, and it's causing this weird... I don't know. There's something up with that. And look at this. Look at this. You can see a liquid in there. See that? There's something definitely wrong here.